Let's look at an example of multinomial probability distribution goodness of fit test now. So we have a market research company, and over the past year the market share for a particular product among the three companies A, B and C. So the historical market shares have been 30% for A, 50% for B and 20% for C. Okay, so those are the historical probabilities. Now let's assume that company C is introducing a new product, they took their product and made it new and improved, and they are now marketing it, and they want to see whether they are gaining market share. In other words, they want to test whether the market shares have changed from what it had been previously. So after marketing it, say they take a sample and then see how many are buying company A product, how many B and how many C. That information is given. So observed frequency 48, 98 and 54. Now we want to test with this observed frequencies whether the market shares are still the same like it had been in the past, or is it different. Okay, let's now set it up in Excel. So population here is market share of the three company products. Now P sub A, P sub B and P sub C are the market share for the product of company A, company B and company C, and the null and the alternative hypothesis are the probabilities themselves. Okay, and the given probabilities are 30%, 50% and 20%. Okay, and we are saying alternative is it's not the same as the null hypothesis, and we want to test it at 5%. And these are the observed frequencies for the three companies. So first thing to do is to set up the probabilities for each of each probability should be set up first. So 50% and 20%. So this is given, and we can color code this as given. So if you sum this, it should be 100%. If you sum this column, and that's your sample size. Okay. Now the expected frequency is sample size times the individual probabilities. So we take the sample size, we need to make that absolute reference, okay, times the probability. Okay, so that's our expected frequency for company A if the null hypothesis is true. Copy that. So now let's put the border back. Now that sum should be the same as the sum of the expected observed frequencies. And you notice that all expected frequencies are greater than or equal to 5, so which means the sample size is large enough. Now chi-squared, as before, observed frequency minus the expected frequency, and square that, divided by the expected frequency. Okay, put the border back again. Now sum that. That's our chi-squared calculated value. The number of categories, there are 3 going like that. Okay, so k minus 1 is the degrees of freedom, and we can test using the table, chi-squared table approach. So that will be chi-squared.inv.rt alpha and the degrees of freedom, and if the calculated value is greater than the table value, then we reject, and in this case it is, so we reject. Okay, reject HO. Now p-value approach, we use chi-squared.dist.rt and the calculated value and degrees of freedom. Now if this is less than alpha value, then we reject, and it is, so we reject. So the interpretation is that the market share has indeed changed now. It is not the same as in the past. And the probability that our conclusion is wrong is just 2.5%. Okay, so this is 2.55%.